right, welcome to Lesson 5.4 Advanced Algebra Notes on Solving Radical Equations. We will jump in pretty much and get going. It's a good lesson. It's based on skills we should have learned and covered in previous courses. Basically, the new skill that we kind of talk about today is that it's okay to raise both sides of an equation to the same power and still have an equivalent or have a true equation. So that's kind of the premise here behind everything. There's not really, other than just kind of saying that here, we'll jump in and kind of start looking at some examples. There's one short note we'll add, but other than that, it's kind of just running through some examples. So let's do it. Here we go. Example 1. Pause it, set it up, you give it a shot, solve the radical equation. All right. So I've got 2 times the quantity, the square root of the quantity x plus 1 equals 4. So the first thing I see, let's jump in. Here's the solution. Get both sides divided by 2, right? Get our 2 out of there. Leave us with the square root of x plus 1 equals 2. So this is kind of the common skill that we'll see all day. As far as how am I going to get rid of the square root? Let's square both sides. We've seen in earlier lessons that square rooting both sides of an equation was a totally acceptable thing to do to get rid of a squared. So you know what? Why don't we, I'm just kind of off to the side here showing here, why don't we square both sides to undo a square root? Now kind of the different part here of what I just showed in the upper right is that 2 to the second power is 4. There's no positive negative to consider here in this case, versus here, what I kind of did off to the side, just going head to head so we can see, kind of some similarities, differences. When we were sitting on this spot right here, without even like solving the equation, we know there's 2 numbers you could plug in there and take times itself to get 16. 4 times 4 is 16, but so is -4 times -4. So that's why when I go to solve using a square root, we needed to consider both positive and negative versions of that square root. Whereas here, different, what we're doing here, we're not able to square root a number and get positive and negative values. So it's kind of taking the negatives off the table a little bit, I guess to say. So 2 to the second power is just 4. There's a single solution here. We'll subtract 1 to finish this. Get x equals 3. We'll see. I'm going to check it. It's the old math teacher. Check your solutions, but we'll see here going forward that it doesn't take much to check them. So here's my check as far as work. So I've got the 2. I'm going to go ahead and plug in the 3 plus 1 and just get a 4 underneath the square root there. Square root of 4 is 2. 2 times 2 is 4. And you say, wow, that's amazing. It checked out. And it does. We didn't make a mistake. But you will see the one note we're going to make involves potentially some what I would maybe call fake solutions or extraneous solutions. So sometimes we're going to solve an equation, not make a single mistake along the way, but get an answer that doesn't work, which is kind of crazy. So we'll see it as we get there. Let's do another one here, kind of I guess a similar concept involving a cube root, but not a whole lot different. We do want to get the root by itself initially. So you can see in both cases here, I'm getting rid of anything outside of the radical. So I've still got my my cube root of 2x minus 9 now equal to 3. And we're ready to roll. Let's raise each side. The entire side's got to get raised, in this case to the third power. Would cancel there and there. I'm left with 2x minus 9. 3 times 3 times 3 is 27. And we've got, a really nice finish here, something that we've been doing for a long time, where I'm going to add my 9 to both sides. Divide both sides by 2 to get x equals 18. Awesome. Very, very quick check here. Again, a lot of the stuff you can kind of do as you're plugging your number in. So my 18 is going in for the x, but I'm comfortable handling 18 times 2, which is 36. 36 minus 9 is 27. So I end up with 27 underneath my cube root. Don't want to forget that. Minus 1 equals 2. The cube root of 27 is 3. 3 minus 1. Yeah, we're good. 2 equals 2. We check out. All right. So hopefully that's like, yeah, we like those. Those are old school equation solving. The one note for your notebook here would be what's called an extraneous solution. What the heck does that mean? Well, basically, when we raise each side of an equation to a power, um, basically when we hear extraneous, we can kind of think of like a fake solution. So basically, um, yeah, you maybe create a circumstance where originally there wasn't a solution, or there was only one solution, but you create a situation where you end up with two solutions, and only one of them is a correct solution. So we kind of put ourselves at a little bit of a risk here by raising each side to a power. So we just need to be aware that, hey, when I get solutions, whether it's a single one like we just did, or multiple, two solutions like we'll see in some future examples, um, we got to check them. Long story short, okay. Let's keep it rolling. I think both of the next two examples involve extraneous solutions. So this one's going back a little ways as far as how we're going to handle this. So right off the bat, I'm looking at it. You paused it, hopefully, and you've tried it, you've attempted it. Otherwise, I guess you're going to do along with me. Um, Moving this one over here is not an option. I can't subtract. There's a wall around this square root here. I can't. 15 minus 1 is not an option. So the minus 1 would have to sit outside here, which doesn't really do much for us. Same thing with the x. I can't subtract an x from both sides and make this 6x, right? This is locked inside this thing. So right off the bat, like we're in a position where we pretty much have to square both sides of the equation. Now here's the thing. I got to square the entire left side. So this is x plus 1 squared, which hopefully we all remember means x plus 1 times x plus 1. That's not just x squared plus 1. All right, right side's all good, right? We're getting rid of the square root, so we get 7x plus 15, which is great, awesome. That was the issue, was the square root. But left side, we got a little bit of a FOIL situation going on here. X squared, 1x, plus another 1x, plus 1, which is going to combine to x squared plus 2x plus 1. Okay, and we're equal to this 7x plus 15. The issue that some of us might have right now is, how do I solve this? What's going on here? There's an x squared, and the radical's gone, which is awesome, which was kind of the hang up initially. But how do we finish this? I'm going to bring everything to the left side. So hopefully as I kind of get into it here, you say, oh yeah, I've seen this. I remember this. We've spent chapters solving equations like this. This is a quadratic, minus 5x minus 14 equation, right? Chapters. So I'm going to try to factor this. We could quadratic formula this. Hopefully, as we're seeing it, I guess I'll kind of scroll it a little bit here. We should definitely, we're basically what we're looking for is two numbers that multiply to negative 14 that add up to negative 5. So hopefully that combination's not too bad to come up with. I think 7 and 2 is the right numbers here. We're going to have to make the 7 negative, and everything works out okay there. So we're going to end up with x minus 7, x plus 2 as how that would factor, which would make my apparent solutions x equals, what makes that 0? 7. What makes that 0? Negative 2. So I'm kind of finishing with x equals 7 and negative 2. Yeah, you on board? Hopefully you remember that. If not, we got to go back. Oh boy, I'd have to dig deep a little bit, maybe less than 2.3 or 2.4, I think, is when we originally covered factoring. Go back, but hopefully that comes rushing back to us. Now, here's what we said. This is probably going to have an extraneous solution. Let's go back and check these. So I'm going to kind of scroll up here, 7 and negative 2, and just rejot them down. I'll kind of clear this stuff. I want to go back to before I did anything. Don't go back to like a mid problem. So we're thinking 7 and negative 2 for my solutions. Here's my check. Whoops, there's a C in there, right? Check on the left side. 7 plus 1, fine, no problem. 8. On the right side, let's see. 7 times 7 is 49. 49 plus 15 is 64. So I end up with the square root of 64. Great. 8 equals 8. I like the 7. We're good. The second one, it's got to be here, right? Now, I'm not saying that maybe there's a chance, which I think there is, it's possible to get two solutions that both work. So that's why it's important to check them both. It's not always the positive number. It's not always the negative number. let's get that -2 in here. So when I go -2 on the left side, I'm getting -2 plus 1, which is -1, right? Hopefully we're following my voice here. I'm taking this -2 and I'm plugging it in. -2 plus 1 is -1. And then what are we getting on the right side? -2 is going in, so I'm getting -14. -14 plus 15 is +1. The square root of +1 is 1. And look how close. I mean, it can be that close where it's -1 versus 1, but that's not true, right? -1 doesn't equal 1. So I want to make sure I take, as far as my solution set, -2 off the books, and just on an answer blank or wherever I'm indicating, like, this is my final solution, x equals 7, and that's it. There is no -2 here. We created that by squaring both sides of the equation right off the bat. All right, so that's what we got to watch out for. We'll see here in the next one, I hope. Another example of potentially how this looks like. This kind of looks like the first two equations we solved, right? Where, all right, fine, we can solve this. I'm going to add 13 to both sides. I've got my fourth root of 4x hanging out on the left still. I've got -2 on the right. We're in a position where, all right, let's get rid of that fourth root by raising both sides to the fourth power. And let's see, over here, root and power cancel out, leaves me the 4x. -2 to the fourth power is +16. I'm going to divide both sides by 4 and say x equals 4. Life is good. That's an easy one just to blow past. We got a whole number solution. We think, yeah, I'm good. But what's the issue here? When I go back and check this, 4 goes in here. 4 times 4 is 16. So now I'm looking at the fourth root of 16 minus 13 is supposed to equal -15. Well, the fourth root of 16 is 2. 2 minus 13, wait a minute, hold on now. 2 minus 13 is -11, not -15. So what's up? Did we screw up? No, we didn't screw up. I'll go back to the spot where we kind of created this just so we have maybe a deeper understanding of what's going on here. But we only got one solution. It proved to be like a false solution. It didn't work. So I don't have to like retry the problem. I'm ready to say there is no solution to this equation, no real number solution to this equation. So this was the spot right here. I don't know if I can pull these red. Kind of. I'm going to try to just get these red parentheses out of here. So if I just kind of look at this line right here, get out of here, that where we're saying, let's take the fourth root of something. You know what, if I just cover up what's underneath here and just say, all right, I want to take the fourth root of something and get -2. If we step back and kind of think about that just conceptually, the fourth root of a number, what number times itself 4 times is going to give us a negative output? And the answer, of course, would be there isn't a number. It's like saying, we'll take the fourth root out of it. I want you to come up with a number that I could square root and get -4. Well, let's see here. 16, no, that's +4. By plugging in -16, the square root of -16 is 4i. What's the deal here? Well, basically, you can't square root a number and get a negative output. So that's the situation that we're seeing, or why there's no solution. By us squaring both sides here at this step, we went from having no solution to creating, oh, we can keep going. That's a +16. Left side was what it was. So where we should have maybe been dead in the water, we were able to. We didn't even see it. We just kind of kept rolling and got a solution. So that's kind of what's behind it there. All right, so hopefully that makes sense as far as check your solutions, check your solutions, check your solutions. What do we got? 1, 2, 3, 4 left. Is that it? Nice. Oh my goodness. Let's run through it here. Kind of a tough one, but well, actually probably the toughest one we're going to see. I've got, again, this 1 here on the left side makes things pretty messy. Whether I have it as +1 here or -1 on the right side, it makes things like pretty tough. Obviously, if this was just x, the square root of x plus 2 equals the square root of 3 minus x, that would be like maybe the complete opposite of, wow, that's an easy problem, where I could just square both sides, be done, and then x plus 2 equals 3 minus x, and we'd say, wow, I love that one. Whoops, But unfortunately, that little tiny one out there kind of messes everything up. So let's take a look. We're basically at a spot where we got to square both sides. All right, let's get rid of those square roots. On the left side, just like we saw a little bit earlier, I need to take the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. So this is what makes this one kind of a beast, in that when I go to FOIL this, the square root of x plus 2 times the square root of x plus 2 is just x plus 2. I get one of these, so 1, so plus 1 times the square root of 2. Whoops, I'm sorry, of square root of x plus 2. I'm going to get another one of those, 1 times plus 1 times the square root of x plus 2. And then all the way on the back end of it, 1 times 1 is 1. Now let's see here. What do we got? Combining some like stuff. These are actually what you would consider like terms, where, like we talked about in earlier sections, these are like radicals, the square root of x plus 2. So those get put together just kind of like in a regular FOIL situation where there's two of them. 2 times the square root of x plus 2. Now I've got a couple other things to combine here. There's this x that's just hanging out front, but then this 2 plus this 1 can turn into x plus 3 plus this right here. So that part alone, I think, makes this kind of tricky. Right side, it's like, wow, sweet, we're good over here. 3 minus x. So I've kind of just been leaving that because that's going to trickle down with us. And you're like, okay, we didn't really undo anything. I would argue, well, we actually there was 2 square roots to begin with, right? We got rid of one of them. The problem is there's still this one on the left side. So if we can move this x, this 3, and this 2 over to the other side, we can probably get rid of this square root right here. So let's see what happens. I'm going to say, let's subtract an x from both sides. Let's subtract a 3 from both sides and just kind of see where that puts us. So minus x minus 3. Now this one's really, really convenient that was a 3 on the left side. So let's see here. X minus x, gone. 3 minus 3, gone. So we're sitting on this 2 times the quantity x plus 2 left side equals right here, 3 minus 3, gone. Now be careful though, because negative x minus x is negative 2x, right? Those don't disappear. Those aren't opposite signs. Negative 1 minus 1 is negative 2. But again, really, really conveniently here now. So I guess I'm still kind of picking strategic numbers to use as far as setting up the examples. We can get rid of that 2 by dividing by 2 on both sides. I'm going to end up with negative x, right? I'm just kind of canceling out there. And finally, we're in a position where we can say, all right, let's do this. Let's square both sides. And by doing that, we can finally get rid of that last remaining square root, x plus 2. And then, again, just watch it here. Negative x times negative x is positive x squared. If we bring everything over to the left side, I'm just going to kind of show it here. X squared minus the x that was on the left side minus the 2. That's where we're at right now. Yikes, even if I just look back and say, now I'm showing everything step by step, obviously for the sake of the notes where you guys can follow and catch all these things. I'm going to look to see, can I factor this? I'm looking for 2 numbers that multiply to negative 2 that add up to negative 1. And, I'm thinking 2 and 1. I don't know if I can make these numbers work. If the 2 is negative, that multiplies out, that adds up. So I think we're okay. Does it work out? Hopefully I'm not screwing anything up here. X minus 2, x plus 1. I'd hate to get this far along and say, oh, no, I screwed up. But I think we're okay. So my 2 apparent solutions look to be x equals 2 and -1. Now, we definitely got to go back here. There's a ton of work going on there as far as squaring and squaring. We actually squared twice, or both sides of the equation twice throughout this solving this equation. So I don't know. I mean, we got to make sure that one or both of these aren't extraneous. So I'm going to 2 and 1. I'm going to come all the way back to the top. 2 and 1. I'm going to write them down. X equals 2 and -1, just so I have them. I'm probably going to have to clear this out here, but obviously, again, if you're watching the example, you should have all this stuff in your notes already. Because really, it just kind of comes down to, do I need to take any of these off the solution set? All right, here we go. Let's check the 2. I always like to check the positive one first. I guess it probably has a higher likelihood of being a solution, but let's see. 2 plus 2 is 4. The square root of 4 plus 1 on the left side. Let's just go ahead and do it. 2 plus 1, 3. All right, let's see what happens over here. 3 minus 2 underneath the radical, so 3 minus 2 is 1. Uh-oh. Square root of 1 is 1. Yeah, no good. All right, so my 2 didn't work. Let's check that -1. I'm getting nervous now. Let's see, -1's going underneath the radical. So if I plug in a -1 right here, what happens? I get 1 underneath. And then plus 1 there. The square root of 1 is 1. 1 plus 1 is 2. We got our fingers crossed. Let's see here. The square root of 3 minus -1. Don't lose track of that minus negative, right? Because it makes all the difference. The square root of 4, 2 equals 2. Oh my gosh, we did it. We got one solution that ended up working out. Now that's actually backwards than what we said earlier. So where's my final answer here? X equals -1. There's an example of us seeing one where the negative value was the one that actually worked out to be the solution. So that's what I said. Like, just be careful that you don't always automatically take off the negative value. That one's kind of a beast. Just be aware. I don't even know if I have any like that on the homework. There might be one at most. Okay, those are kind of tough. I think the rest of the 3 fall right into our wheelhouse, though, as far as difficulty level, ones that we should be able to do. So let's crank them out here. Again, you're pausing to start the problem. Actually, one last kind of new concept that these all involve. Not new in the sense that we got to start over from scratch or anything, but they all involve, instead of radicals, these all involve rational exponents, these last 3. So I'll show you maybe a trick or whatever to kind of fix this in a single step versus having to always rewrite this in radical notation. So just like before, I want to get rid of this 2 here to start. So we'll subtract 2 to start. So now I'm sitting on the 2x to the 3/4 power equals 8. All right. So one thing you could do is we hopefully, based on previous lessons, you could rewrite this if you wanted to as this. Right, I've taken the 4th root of 2x and raising that to the 3rd power. How am I going to undo all this stuff? I'm going to have to cube root both sides to get rid of this 3, and then raise each power to the side to the 4th power in 2 separate steps. So I'm not a huge fan of this. Not that it's wrong, not that we couldn't get to where we want to get, but how can I take care of that in one fell swoop? What if I raised each power to each side of the equation to the 4/3 power? The advantage there is I get 2x to the 12/12, which is 1. So I can get rid of that rational exponent just like that, raising each side to would be the reciprocal power. Now on the right side, we could potentially have a messy number. This actually works out to something we should be able to do without a calculator. It seems kind of crazy, but the cube root of 8, which is 2, all right, I'm doing that part first. The cube root of 8 is 2, and then 2 to the 4th power is 16. Holy cow, that actually ends up finishing really nicely. X equals 8. Very quick check. Nothing changes as far as, do we have to check these ones? I would say, yeah. 8 times 2 is 16, so you could, on your calculator if you need to, 16 to the 3/4 power plus 2. Hopefully that works out to 10, or we could do it without. All right, the 4th root of 16 is 2. 2 to the 3rd power is 8. So 8 plus 2, absolutely, is 10. So you still run the same risk as far as, losing track of or creating an extraneous solution with a rational exponent. All right, so that's the big reveal there, I guess. When we have this situation, you don't have to rewrite it. I wouldn't rewrite it. Just raise each side to the reciprocal power. Get rid of anything there first. Now here, we don't have that issue of getting rid of anything that's not being taken to that power. I'm right away going to, let's raise this side to the 3/2 power. Okay, left side, we're going to get 3x plus 4 is now sitting solo. 16 to the 3/2 power, that's like the square root of 16, which is 4. 4 to the 3rd power is 64. And then we end up with a fairly nice finish. We'll subtract 4 from both sides. We'll divide both sides by 3 to get x equals 20. Hopefully, quick check here. 20 times 3 is 60, plus 4 is 64 to the 2/3 power. Hopefully is 16. The cube root of 64 is 4. 4 squared is 16. Yep, I like our answer. I think we're okay. Awesome. X equals 20. Last but not least, are we going to get an extraneous solution? I'm going to bet. You know why? What kind of gives it away a little bit, although not automatically, there's an x on both sides here. So you can see kind of what's the first thing we're thinking we should be doing to this to get rid of that 1/2 power? Why don't we raise each side of the equation to the 2nd power? Left side, awesome, gets rid of that. X plus 30, sitting solo. Right side now is that x squared scenario, which if you didn't get the earlier one, here's your chance for redemption. Let's bring everything over to the right side this time. Why the right side? I would say when at all possible, we'd like to keep this leading coefficient as +1. So we're going to be in better shape if I bring the x and the 30 to the right side. So x squared minus x minus 30 equals 0. So we're going to look for two numbers that multiply to -30 that add up to -1, and that should be one. That the first combination I think of is 6 and 5, and I think we can make that work if I make the 6 negative. So we'll factor to x minus 6 and x plus 5 and say that, all right, I like 6 and -5 for my apparent solutions. If our factoring's decent, like that's actually kind of a quick finish, not a ton of lines of work there. Let's just check it. All right, so I do have to kind of clear off my original here. I can't even read it. Let's see what we end up with. Maybe they both work. Who knows? Plug in the 6. So 6 plus 30 is 36. 36 to the 1/2 power. We're hoping that I'm plugging in a 6 in both spots here. So 36 to the 1/2 power is like the square root of 36, which is 6. Awesome. Yep, checks out. So 6 is good. Let's see what happens with the -5. Can I squeeze it in here? -5 plus 30 is 25. So 25 to the 1/2 power is 5. That's a nice number. But unfortunately, on the left side, on the right side, when I plug in x equals -5, it's got to go in here as well. Yeah, so I end up, they're usually pretty close like that, where it's the same number, just opposite signs, but they're not equal, right? Clearly not equal, opposite. So I want to make sure I remove -5 from my solution set and just say, all right, x equals 6 for that one. Wow, we did it. 10 slides. Well, 9, including the introduction, which we'll go back and refresh like we usually do. We ended up with, we solved a whole bunch of equations. What, 1, 2, 3, 4, 5, 6, 7, 8 different equations, all with slight different nuances, wrinkles, or whatever you want to say. They had radicals and rational exponents, and then we learned what it was to check for extraneous solutions. So we've definitely covered it all. 5.4 is officially done. I will see you in future lessons.